Okay, in this video, we will discuss about the Euler method. This method is used to solve ordinary differential equations. It is used to solve ordinary differential equation numerically. So let us consider a differential equation like y dash is equal to dy by dx, which is equal to f of xy. Y dash equal to dy by dx, which is equal to f of x comma y, and this is given, and the initial condition also given, y of x0 equal to y0, y of x0 equal to y0, which means that at x0 what is my y value, that is initial value. Okay, so at initial value of x is x0, initial value of y is y0, so that y of x0, value of y at this x0, initial x point is y0. That is my initial condition. Okay, now what will be the value of y at a point xf? What is the value of y at xf? That is what we had to find out. So in order to find out this, I have to know what is xf first. So if you are considering your differential equation like this, okay, so this is your differential equation, and in this y-axis, let me consider the y-axis as your y, that is a d, this is nothing but dy by dx, okay, and this is x. So for x0 you will be having value which is y0. So let me put that in a different color. Okay, so this is your x0, and at x0 you are having this value of y, that is dy by dx value, that is y0, and so in this way you split this region into large number of this entire function. You consider different values of x and split into different region like this, and so on up to this. Okay, so in such a way that if you zoom this region, then you will get the spacing like this, x values like this. So this is your x0, then you are having x1, x2, x3, etc. Okay, so the change in this x value, if you take this change x1 minus x0, this is x1 minus x0, this will be h, that is your period or the step size. Okay, so the period is h or step size. So that is given by x1 minus x0, and this is equal to x2 minus x1, x3 minus x2. All those values will be equal to h. So this is equidistant. Okay, eq spaced. Okay, so these are eq spaced. These are eq spaced. All these things, these are h. So if you want to find out what is, so from here we can say x1 equal to x0 plus h. Similarly, x2 will be equal to x0 plus 2h, x3 equal to x0 plus nh. And if you consider the final value as xf, then that will be equal to x0 plus nh. Xf equal to x0 plus nh. Now the question is, what will be my y value at this point? So how we can calculate that? We have the initial value at so y of x0 we know, that is y0. Now we have to calculate the other values at a different x for this particular case numerically. So we are having only the equation, the differential equation. So that differential equation is dy by dx equal to f of x comma y. So if we integrate this equation, then we can write this is equal to, from this, if you are integrating this equation, then we can write y equal to, this will be nothing but integral f of x comma y plus some constant. Let's take it as y0. So that is the initial value for y, that is y0. Okay, that's why we are writing this as y0. Now, how we can do this integration? This is we can write this integration as y equal to this integral. I am saying so. This is y equal to h into f of x0 y0 plus y0. So in this case, you can take it as generally some constant value. So if you consider initial point, so I'm just varying from x1, sorry, x0 to x1, changing value from x0 to x1. So at x0, we are having value y0. What will be the value of y at x1? So I will take it as y1. So y1 will be h times f of x0 comma y0 plus y0. And this is only possible when h is very small. H is very small and f of x0 comma y0 equal to is a constant, or I can say f of x0 y0, this is equal to f of x comma y. I'll just erase this one. So in this case, let us consider f of x comma y, that will be equal to f of x0 y0. So if you are considering your variation from x0 to x1 in such a way that at x0 we know this function is f of x0 comma y0, right? At x0. And if you consider the same function at x1 also, x0 comma y0. At x1 also we are having same function, which means that when you are changing from x0 to x1, the function remains constant. Okay, that is the condition. In that condition only we will get this result. So in this case, what is the what you are considering when you are considering x0 to x1 variation? So the integration will be y equal to integral that will be from x0 to x1 f of x comma y, and this one will be y0, and this is x0 to x1 f of xy. But in this case, if you consider this function is constant for a very small change in x, that is from x0 to x1, in such a way that h is very, very small. So in that case, this f of x comma y can be written as f of x0 comma y0, and that is constant in that variation from x0 to x1. So that this I can take outside. Okay, so that the integral will become, because in x1 and x0, f of x comma y, which is constant, that is f of x0 comma y0, and then the integral will become this times x0 to x1 dx. And what is this value? X0 to x1 dx, integral x0 to x1 dx is nothing but h, that is step size. We have already told. We have already discussed this x0 to x1. If you consider what is the change in x, that is nothing but h, right? So this integration give you value h, so that you will get this result y1 equal to h in f of x0 y0 plus y0. So this is only possible when f of xy equal to f of x0 y0 for, and in such a way that this h is very small. Okay, and we are considering this function is constant in that interval x0 to x1. So in that case, you can write this particular expression for y1, that is the value of differential equation at x1. Similarly, you can write y2, which is equal to h into f of x1 y1, and here we are considering the values constant between x1 and x2. So this is x1 comma y1 plus this is y, this is y2. Similarly, y3, value of y at x3, that will be h into f of sorry, value of y at point x2, that will be y2 x2 y2, f of x2 y2 plus y2. In the same way, if you continue, then we'll get yn, this will be equal to h into f of x n minus 1 comma y n minus 1 plus yn minus 1. Okay, so this equation, you can also write this as yn plus 1 will be equal to h into f of xn comma yn plus yn. And this particular method is called as Euler's method. So you can calculate any value of y. If you are having a differential equation, you can calculate any value of y, okay, corresponding to any x value by using this equation. That is the basic idea of solving differential equation numerically. So here we have this general equation yn plus 1 equal to yn plus h into f of xn plus xn comma yn. And this is for first order differential equation. We have considered y equal to dy by dx. Now what will happen if it is d square y by dx square, second order differential equation? So in the case of second order differential equation, split it into two first order differential equation first, then solve it simultaneously by using Euler's method. Okay, so first we have to consider if you are considering d square y by dx square as a second order differential equation, first you consider dy by dx, solve for this by using Euler's method, solve for this y, and after that, at the same time, okay, simultaneously you have to go for what is d by dx of dy by dx. So this is first differential equation, then again do the same for this second differential equation. So we have to split it into two differential equations, first order differential equations, and then solve it simultaneously. For example, if you consider the free falling body, and that is having an equation d square y by dt square equal to minus 9.8. So for example, if you consider any point from any point a body is falling down, so in this case, if you consider the acceleration due to gravity as g, and so that the equation will become, if you consider this as your y-axis, okay, this height you are representing with y, okay, y-axis. So we can directly write this d square y by dx square, sorry, d square y by dt square, that is equation of motion for this case. And actually it will come m times d square y by dt square plus m times g equal to 0. But here we are considering, we are not considering the mass here, just consider for a unit mass, okay. So in that case, m will become 1, so that d square y by dt square plus 9.8, that is nothing but your g value, this will be equal to 0 for a unit mass. So this is d square y by dt square plus 9.8 equal to 0. That is equation for freely falling body, right? Or you can write d square y by dt square equal to minus 9.8. So in this case, you are having a second order differential equation d square y by dt square. So first you have to consider dy by dt. So I will consider dy by dt, and this is nothing but velocity, as you know. And this velocity I will take as function 1, that is differential equation 1 of first order. So this is t comma y comma v, f1 that depends on t y v, function of t y v, okay. And next we have to take dv by dt, that will give me d square y by dt square, and this is equal to, if you take dv by dt, that is nothing but the the acceleration, as you know, and this I will take as f2 of t comma y comma v, another function. So dv by dt is nothing but minus 9.8, so you know here, or you can take this as in program we will explain this. So anyway, so we can define, or we can split this d square y by dt square into two first order differential equation like this, dy by dt and dv by dt. So this dy by dt is nothing but v. We are treating it as v, and we are taking this dv by dt, so that we'll get finally d square y by dt square. And if you consider dv by dt and minus 9.8, this has to become 0. This is I think this is plus, right? Plus 9.8. This will be equal to 0. So this is the concept. Okay, so this we have to do. So as you can see here, this will give me equation of y with respect to time after solving this. So dy by dt, if you are doing this one, you will get yn equal to here, yeah, yn plus 1 equal to h into f of t comma y comma v plus yn. We're calculating for that yn plus 1. So this can be calculated easily, as we discussed earlier. Okay, and just use this y and substitute that y value in here and calculate what is f2 for that particular time and v, so that we will get the value of dv by dt. Okay, just calculate. So here we are, okay. Here we are getting v. So v you substitute here, and then height also, you know, that y value, that is this value. You substitute that initial value has to be given for that height, and substitute all those value and find out what is f2. Then you can directly calculate this dv by dt. Okay, so this gives evolution in v with respect to time, and that will be given by this equation, that is v equal to, or we can write it as vn. In this time it will be vn plus 1 equal to vn plus h into f2 of tn, yn, vn, all those variables. So that depends whether you are calculating that from the initial point. If you are considering x0 y0, then only you have to consider these n values. That depends. Okay, so it just depends on this equation. So in this case, I am considering at y0 representing the value of y at x0. Okay, in that sense, we'll get yn plus 1 will be this value, this value. In the same way, you can calculate the value of v, or value of f2, by using this equation. So basically we have to do it twice, do the same procedure twice simultaneously in the same program. If you want to calculate the or solve the second order differential equation by using Euler's method. Okay, so first you have to solve this for getting this dy by dt corresponding to this v. Then again use that result and solve for this dv by dt, okay, by using this particular equation. Okay, so let us discuss the program for this freely falling body, and you will be able to understand it more clearly. Let me see. Let me share one other window. It is nothing but ideally. We'll just stop this. We'll just share another window. Okay, now you can see the window. I hope you can see this. Yeah, I will just close this one. Okay, you can see in this program, I'm just importing matplotlib. From matplotlib, I am importing this pyplot. As you know, this is pyplot, and I'm importing it as PLT. Okay, then I have defined V. The value of V is initialized with 0, and that is the velocity, and T is time, that is also initialized with 0, and H is the step size, under the step size, or the time step. Okay, this I can replace with the height. Height. So in each time we are considering initially the particle or the object is at a height h, or we can, in this case we are considering y as your height, so we consider it as the maximum size, maximum height is y. So initially the particle is at height y, and in each time we have to decrease that height. Okay, by while falling, that height has to be decreased, and that how much in each time, how much it should decrease, that is given by this h value. Yeah, that is nothing but the height step by which the height decreases. Okay, so we have to provide that value of h, and then we have to enter the height, that is the maximum height, enter the height, or we can say this is initial height, initial height. So the body is falling from an initial height of y, and each time this initial height will be decreased by an amount of h, that is the step size. And I have defined three empty list: time, position, and velocity. For time, position, and velocity, whatever value which is calculated for time, for different time, at that time what will be the position and what will be the velocity, all those values will be appended to this empty list. And then I have print tvy. This is just to for the table formation. I'm just printing this t string v character as well as y character, y representing my position, and that is height, v is for velocity, t for time. And I am considering here 10,3, that define the spacing. Okay, or in this case, just I'm using the same spacing here also. Okay, so you can see that while printing that particular variables. So then I am checking while y is greater than 0, which means that my height is greater than 0. If it is greater than 0, then I have to go to these steps in that while loop. So first I have to print what is the current values of t, v, and y. Okay, here I am considering this as characters, strings. So it will be directly printed as strings, like a heading for the table for each column. And here we'll be having values t, v, y. Each of these are values which initially we have given it as 0. V and t we have given it as 0, and y we have to provide what is the height. So those values will be printed initially. Then we have to go for this step, where we will calculate the value of v. Okay, and the value of v is nothing but v plus minus 9.8 into h. So you can write this as your function. Okay, in both way you can write this. You can directly consider f1 and f2 and define that function somewhere here, and you can call that function after writing v equal to v plus some h times f2 or f1, something like that. Like that you can do. Okay, otherwise you can directly write those functions here, f1 and f2. So I'm just writing those functions here. In this case, I'm just writing those functions here. This is my f2 that we have already explained in theoretical part. Dv by dt, if you consider, that will be minus 9.8. That is equation, right? So dv by dt is nothing but my f2 of x comma y, second differential. Okay, so that will give the f2 value. So you can write this as f2 somewhere here, f2. You can define some function which is equal to, which is f2, and you can return this value as your f2 minus 9.8. And f1, you can define f1 value, which is nothing but dv. Okay, and that is that will be, I will just change this. This one I have to calculate, right? So let me put it back. Okay. So you can see here we have to calculate what is the value, next v value. Then I have to calculate what is the next value of height after that. If you are having that v value. Okay. So in here also we can define function f1, for example, and you can put f1 equal to v in that particular case. I think f1, yes, f1 is v, right? Because we have to take dy by dt. So that is nothing but v. So that in that way you can define this as your f1. So this entire term will become y equal to y plus f1 into h. That is same expression. That is same expression. So if you are calculating y1, then this will become y1 equal to, this is nothing but y0, that is initial y, that is current y value, plus f1 is v into h. Okay, that is same expression. If you are defining f1 and f2 somewhere here, you can do like that also. Okay, so then we have incremented time by time also, t equal to t plus h. Time is incremented by the same step size, t equal to t plus h. And then yes, then so when we increase this time t equal to t plus h, automatically when this the program runs, the y value will change. Each time when you're changing this h value, this v is going to change. When v changes, this value also will change. And this t equal to t plus h, I think this is not necessary in this case. If you want to calculate the time of flight, then only we require this. Okay, so we can just remove that, or you can just keep that, because we have to plot the velocity versus time or position versus time graph. So in that case, we need that. Okay, so initially t equal to 0, then each time we are increasing that t by uh, h. Okay, so whatever h value we are considering, that will be considered as in seconds. In physical situation, it will be considered as seconds. So if it is 0 second, 0.1 second, then 0.2 second, like that, it will increase in time. So we are taking same size, same step size, which means that in if you are considering h equal to 0.1, then time is increasing by 0.1 second. So in each of those 0.1 second, we are getting a change in your y value by this. Okay, so you just substitute 0.1 here. So 0.1 into 9.8 will come in this bracket, and that is subtracted from the initial velocity. That is the velocity, the current velocity. Okay, So this is nothing but v equal to u plus at, that equation. Okay. So okay, so this one, after considering that time, then we just consider the appending instructions. That is nothing but in time empty list, I just have to append all the t value. And then for position empty list, I'm talking about this empty list, we have to append all the position values, append y, that is nothing but the position, and then velocity vel dot append all values of v that we calculate here in each step, in each edge value. So this program will continue, this loop will continue until this condition become false, which means that when the y will become 0, which means that the body falls down and reaches at the ground, then this y will become 0. Okay, at that time this program, this while loop exit, and this directly go to these instructions, and it will plot these plots. So this is plt dot figure 1 for first figure, and I have given title of that figure as position versus time, and plt dot plot time comma position. So the values of this list, time and position, will be taken to plot that particular graph. And then we have defined second figure. Sorry, we just have to plot the second figure. So plt dot figure of 2, and then plt dot title of that figure I have given as velocity versus time, and then plt dot plot, that is nothing but the values, that is we have to give time and velocity from these two lists, and just show those two graphs. So this is the entire program. Okay, if you have any doubt, you can just compare these steps with the theory part that we have discussed. Then you can see this is nothing but your f2, and f2 of that t comma v comma y, and this v is nothing but your f1. Okay, so that we already discussed in the theoretical part. So this is the program of the freely falling body by using Euler's method. Okay, so let us check what will be the result of this. I will just run this. So you may not be able to see that window. I will share that window now. I will just stop this and share that window. Yes. So this is the window that is corresponding to this window will appear when you press enter from that IDLE window. So this one, first it will ask me enter height step, that is with what value the height has to be decreased. So I will just put 0.01 here, and then press enter, and enter initial height, at what height the body is falling. So let us put it as for example 5 meters. Okay, and press enter. So it will calculate all the values. It will calculate all the values. You can see here all the values. So also it is the graphs also printed, but you may not be able to see that because it is in another window. I will show that again. Anyway, so these are the values for each step size. You can see here for first value we are having 0 0 0 0 for velocity and time, but at that time height is 5. Then my h is increased with 0.01, so that time increased with 0.01 because t equal to t plus h. Then at that time velocity is calculated and it is minus 0.098. Okay, you have to consider that equation for velocity, and you will get minus 0.098 as your velocity. Then correspondingly the height will be decreased to 4.999. then it will be decreased to 4.997 and so on. So all those values are listed here because we have given list is for time, velocity, and position. So that is what we are printing here. Okay, after that we have to get the plot also, right? So I will show that plot because it is coming in another window. That's why we are not able to you are not able to see that one. So let me see what. Okay, I think run it again. 0.01, then 5. Yes. Okay, now you can see this one is representing the velocity time graph that we have plotted. I hope you can see that. Yes. So this is the velocity versus time graph. This is just by using that list of values, just plot those values. You can also give the X label and Y label that I didn't provided here. You can use the grid points, all those things. Okay. Just I have given the velocity versus time as my graph title, and this is how it look like with the increase in time. So this x-axis representing time, y-axis representing velocity. Okay, and then we have to consider the next graph that also we have included in our program to show. So the second figure we have to consider, that is nothing but the velocity versus position versus time graph. Maybe this one will be the first. Yes, this one is the first one in program. Okay, so I will just share that one. Okay, so this is the first figure, that is the position versus time, and velocity versus time we have given it as second figure. But I have shown explained in the reverse way. Okay, anyway, it is not a problem. So this is the position versus time graph of that freely falling body. As time increases, how the position is changed, and at 1, you can see that will become almost 0. The height will become almost 0, which means that the body reached in ground. Okay. So this is the program for freely falling body, and by using Euler's method. This is an example for Euler's method. You can work out some of the numerical examples in this Euler's method to solve differential equations.